YouTube channel MacPM. So in today's video we will solve a stress and strain numerical problem. So let's see the problem. A brass bar having cross-sectional area of 1000 mm square. So cross-sectional area of this bar is A is equal to 1000 mm square, is subjected to axial forces shown in the figure. So you can see here 50 kilonewton on left, then 80 kilonewton here, then 20 kilonewton, then 10 kilonewton here. Find the total elongation of the bar, modulus of elasticity of brass is. So E is given, modulus of elasticity or Young's modulus is given as 100 giganewton per meter square. This value of E, we have to find delta L or total elongation. So first of all, we have to calculate what is the effective force on each part. Okay, we will draw free body diagram of these three parts. This is LM, see here LM. Then we will draw MN portion here. Then NP. This is NP. So we will try to calculate forces on each portion of the bar. So here you can see we have 50 kilonewton. Here we have 10. So to balance, to maintain the equilibrium, here if it is 50 kilonewton, then here also it should be 50. Okay, but you can see in the diagram here it is 80. So 50 in this block, then remaining 30 should be here. Okay, so if here it is 30 kilonewton, say again here it is 50 kilonewton, you can start from one side, either from left side or right side. So I am starting from left side. It is here 50 kilonewton. So if one side is 50 kilonewton, then other side also it should be 50 kilonewton. So here it is 50 kilonewton, but here in the figure you can see it is 80 kilonewton. So 30 kilonewton, 80 minus 50 is remaining. So this 30 kilonewton will act on next block Mn. So 30 kilonewton, but here you can see it is only 20 kilonewton. But we, to maintain equilibrium, here it is 30, so we will put 30 here. But here it was only 20, so 10 will be in opposite direction. So here 10 kilonewton, here also 10 kilonewton, so it is balanced. Again, if you want to start from right side, so see here it is 10 kilonewton, so in equal and opposite direction, here it will be 10, but there is no force here. So if you are applying 10 in this direction, right direction, then 10 should be applied in left direction also. So 20 plus 10 will be 30, and here also 30, remaining 50 will be here. Okay, so we have to find delta L, means total elongation. So total elongation will be equal to elongation in this plus this plus this. There are three parts, so we can write delta L1 plus delta L2 plus delta L3. This is the elongation in these three parts. Now how to find the elongation? Now we know that modulus of elasticity is equal to stress upon strain. Now stress is P by A, or equal to force upon area, and strain is delta L by initial length, which is equal to PL upon delta L into A. So if you have to find delta L, then you take here E will be coming down, so delta L will be equal to PL upon AE. So total elongation will be delta L is equal to delta L1 plus delta L2 plus delta L3, which will be equal to P1 L1 upon A1 E1. Suppose this is 1, this is 2, this is P3 plus P2 L2 upon A2 E2 plus P3 L3 upon A3 E3. Now you can see that area is same, cross-sectional area is same for every each block. E is also same because all are made from brass, so it will be common. So 1 upon AE in bracket P1 L1 P1 L1 plus P2 L2 plus P3 L3. Now you can see one thing, that this block LM is in tension, so its length will increase, but these two blocks are in compression, so their length will decrease. So this which we have written P2L2 and P3L3, these will be negative because they are contracting, or length is reducing. So we can write it as 1 by AE in bracket P1 L1 minus P2 L2 minus P3 L3. If these three all were in tension, then we will add all three, but these two are in compression, that's why we are writing negative here. Okay, so we will write 1 upon, what is the area? Area is common for all, which is given as 1000 mm square. So we will write 1000 mm square. If you convert in meter square, then it will become into 10 to the power minus 6 into E is 100 gigapascal, so into 10 to the power 9 in bracket P1 is 50 kilonewton, so 50,000 Newton into L1 is 0.6 meter, 0.6 plus P2 is, this is minus 30 into 1 meter length minus 10 kilonewton, sorry, it will be into 1000 it will be 30,000 because it is 30 kilonewton into 1 minus 10,000 into 1.2 meter, so it will become 1 by 10 to the power 5. This 1000 will be common, it will come out 10 to the power 3, 1 by 10 to the power 5 into, if 50 into 0.6 will be 30, minus 30 into 1 will be 30, minus 1.2 into 10 will be 12, so it will be 1 by 10 to the power 5 into minus 12, so it will be minus 0.00012 meter or minus 0.12 mm. It is minus, negative sign means it will be contraction, 0.12 mm. So that's the answer. I hope you understand how to solve this problem. If you have any doubt, then please ask in the comment section, and if you liked our video, then please subscribe to our channel. Thanks for watching.